So ethers themselves, an oxygen bonded to a carbon on each side, and remember those capital R's are any carbon chain, that's not a particularly reactive functional group. And that's the reason why ethers are often used as solvents, because you can mix a bunch of stuff with them and the ether won't react. But you can change the ether, not change the functional group, but change the R groups, the carbon chains, to make ethers more reactive. If the two carbons that oxygen is bonded to are forced together in a ring, then that molecule becomes reactive. And the reason is because each of those carbons here have 4 single bonds, so they're both sp3 hybridized. And that means that they would prefer to have bond angles of 109.5 degrees. But in this molecule, these bond angles are 60 degrees in both of these places. And so you're forcing the bonds to be much closer together than they would like to be. And that creates strain in the molecule, strain because of the ring that you formed, and so it's called ring strain. And that ring strain makes this type of an ether very reactive. Now this particular molecule, with 3 atoms in it, 2 of them carbons and 1 of them oxygen, that particular molecule is called oxirane. So this is oxirane. That's just one molecule, though. You can imagine a whole class of molecules that are based on oxirane. Oxirane with different branches coming off, or oxiranes appearing in different carbon chains. And those molecules of oxiranes with a whole bunch of branches, those are called epoxides. The E in epoxides should sort of remind you of the E in ether. These are reactive ethers, reactive because of the ring strain. So, there are really 2 ways to name epoxides, but we'll go through just one of them, the main one, the one that you would be able to use to name any epoxide, and that is to take the epoxide and to treat it as a branch. Now it's going to be a very special branch. The name of this branch is going to come immediately in front of the backbone name. That's the one sort of exception about it. But otherwise we're going to treat it as a branch. So the first step would be to look at the molecule and find the longest chain you can without going backwards or lifting up your pencil. The longest chain you can, and that will be the backbone name. So if you go from left to right, you get 3 carbons. That backbone would be 3 carbons long. If you go down, you 3, so it looks like the backbone here, the longest carbon chain you can find without going back or lifting up your pencil, is 3 carbons long. So I'm going to circle that. That's going to be my backbone. Now, because that has 3 carbons in it, the prefix to name that backbone will be prop. The bonds here are all single. The infix for all single bonds is AN, and in the backbone, in the circled area, you only have hydrogen and carbon, and so the suffix will be E. So propane is the name for that backbone. Now we have a couple branches. Let's deal with the branch that we would be more familiar with, this branch here. That branch is coming off of carbon number 2, and so we'll have a 2 in front. In this branch, there's only 1 carbon, and the prefix for 1 carbon is meth. And because it's a branch, immediately after the meth will come YL. So that branch is called 1-methyl. Alright, now let's deal with the new thing, the epoxide. The epoxide is attached to 2 carbons, the oxygen, and so we are going to give the numbers for both of those carbons, 1 and 2, separated by commas. And the name for this branch, which is very particular, it's just 1 atom, an oxygen atom, that boomerangs right back onto the molecule. The name for that branch is epoxy. So this whole thing would be 1,2-epoxy. Okay, now the one particular thing we mentioned is that epoxy branch has to come immediately in front of the backbone name. It's just sort of an exception because it's so intimately tied to the backbone. Otherwise, you put the branches in front, And so the name for this molecule would be 2-methyl 1,2-epoxy propane. Let's try B, this one here. So, first step, find the longest chain. Now this one, the longest chain really just has 2 carbons. Remember that if you ever have rings, you consider those separately. Here the rings are special, and they're benzene rings, but they don't have any functional groups on them, so they wouldn't be the backbone anyway. This carbon chain here has the ether functional group, and so you'd want that to be the backbone. And so our backbone is really just going to be 2 carbons long, right here. So let's name that backbone. Once we have a name for that, we'll think about all these other branches. The prefix for 2 carbons is F. In the backbone, we have only single bonds, so that's the infix would be AN. And then in that backbone also, the circled area, we only have hydrogen and carbon, and so the suffix would be E. So far we have ethane as the backbone. So now let's go through each branch. Let's start with these benzene rings. Now, the name for benzene, the name for these 6-membered rings with alternating single and double bonds is, of course, benzene. That's what it is when it's by itself. But when benzene is a branch coming off of a backbone, it's named phenyl. Phenyl with a YL. So the name for this branch is phenyl. The name for this branch is phenyl. And so those are those 2 branches. Whenever you have more than one of the same type of branch, you can sort of smush them together. Just make sure you put a prefix that tells you how many you smushed. So here, we're smushing 2, so we'll have the prefix di, and then phenyl. Phenyl, YL. All right, we have one more branch. This is the new part. The branch is this oxygen here, and that oxygen is attached to 2 carbons, to carbon number 1 and to carbon number 2. So this is going to be 1, 2. The name for that oxygen branch that boomerangs right back is epoxy. So we have 1, 2 epoxy. Now I should mention something about the numbering here. We numbered it from the top to the bottom, but actually, no matter how we number it, we get 1 and 2 for the epoxy. That's the more important thing. But if we number it from the bottom to the top, we get lower numbers for the phenyls. Here, we get 1 and 1 for both of these phenyls. The way we had it before, we would have gotten 2s for those. So the names for these phenyls will actually be 1,1-diphenyl. All right, so now we just have to put these pieces together. Ethane, the backbone name, of course, comes last. The one exception you want to remember is that the epoxy name comes immediately before that because that branch is so intimately tied to the backbone. And then in front of that are whatever other branches you have. So here, that would be 1,1-diphenyl. So the name for the whole molecule would be 1,1-diphenyl 1,2-epoxy ethane. Beautiful name. And for C. So C, we really only have one backbone option. Oops, it is this ring here. That's our only carbon chain. And so we have 1, 2, 3, 4, 5, 6 carbons. The prefix for 6 carbons is hex. In that ring, we only have single bonds. The infix for all single bonds is AN. And also in the backbone, we only have hydrogen and carbon, so the suffix is E. So that's hexane. It's going in a ring, and to say that, in front of that we'll put cyclo. So cyclohexane. Now for our branch. This is our one branch, and that branch is attached to carbon number 1 and to carbon number 2, and it is an epoxide. So it's called an epoxy ring because it's that 3-membered ring with oxygen being one of the members. So the full name for this, the backbone goes at the end, the full name for this molecule would be 1,2-epoxy cyclohexane.